Hello, everyone. Welcome to What Does AI Look Like When Archival Concepts and Principles Inform Its Development? My name is Luciana Duranti. I am a professor of archival studies in the School of Information at the University of British Columbia in Canada. I am also the director of the Interpares project. Today, I will initiate the webinar and then I will moderate the presentations and the discussions. So, yes, what does AI look like when archival concepts and principles inform its development? Well, first of all, what do we mean by AI? Artificial intelligence systems are computing systems that use algorithms capable of carrying out complex tasks that once were the domain only of natural intelligence, such as processing large quantities of information, calculating and predicting, learning and adapting responses to changing situations, recognizing and classifying objects, etc. Can we develop artificial intelligence systems for carrying out records and archives function in a competent and efficient way, at the same time respecting the nature of the records and ensuring the continuity of their trustworthiness? Well, for a moment, I need to be precise here. We talk records, artificial intelligence people talk data. So during this entire presentation, when we speak about data or content data, we are not referring to datum data, the smallest meaningful unit of information, as we usually do in archival science. Rather, we are talking about records or archival documents. That is, we are talking about any document, of course, information affixed to a medium with a stable content and fixed form, made or received in the course of activity, and kept for further action or reference. Now, because of the circumstances of its creation, all records have certain characteristics. They are natural byproduct of activity. They are interrelated to all the records participating in the same activity. They are impartial with respect to the questions that researchers may ask of them in the future. And they are authentic with respect to their creator if they have been used as a means for its activity. Now, any AI tool that we can possibly use in the process of carrying out records and archives related functions must ensure that these characteristics, naturalness, interrelatedness, impartiality, and authenticity, are protected, that the records remain innocent, that is, trustworthy. So, why we don't just take AI and apply it to the records? Well, because artificial intelligence systems have issues that don't go very well with the purposes of archives. So artificial intelligence system may provide evidence that being based on probabilities may be inconclusive, or evidence that is not transparent and interpretable, or evidence that is only as good as the data that we feed the tool, the AI tool. Or this sort of evidence may have a disproportionate impact on one group of people or another. Or it may provide challenges for autonomy and privacy of people. And it is very hard to assign responsibility for the outcome. In addition, the decisions that artificial intelligence systems make are usually based on past decisions. And when it comes to human affairs, tomorrow rarely resembles today. And data and numbers can't say what has a moral value or what is socially desirable. So in 2018, Canada and the Association of Southeast Asian Nations developed a Montreal Declaration that listed a number of principles, 10 principles, and stated that any AI tool that we can use should respect these principles: the well being of people, the autonomy, the privacy of people, but also principles of solidarity, of democratic participation, of equity, diversity, inclusion, prudence, caution, responsibility, and there should be a sustainable development of these tools. Now, there have been several projects looking at AI in archives, and in fact, in the International Council of Archives, there has been much discussion of this project. Now, they typically look at a particular tool in a specific context or even a single set of records. Recurrent neural networks have been used, for example, for classification of the content of large aggregations of records. Recommendation systems that connect relevant images to digitized letters by using handwritten text recognition have been used to make old documents searchable. Chatbots that emulate human conversation through voice commands or text chats or bot have been used to help knowledge seekers, users in general, to find connected information. And the combination of named entity recognition, entity relations tools, and topic modeling have been used to create visualization tools for the types of data stored on these images. Now, the archival problem is that relying on existing off the shelf tools, as the past studies on AI in archives have done, limits the challenges that can be met. And it makes the needs of archives subservient to the larger field of machine learning. It may be practical, but many tangible instances of biases have been found in modern machine learning models, often driven by laissez-faire data collection practices. Now, this raises the question of, number one, whether off-the-shelf tools are the best solution for the archival field, and number two, whether what AI could look like if it was instead archival theory that informed the creation of the tools. So we developed a new inter pares project called I Trust AI. The I Trust AI project is the fifth phase of the inter pares project, directed by myself and Mohamed Abdul Majid, who will speak later, and funded, like the previous phases, by the Social Sciences Humanities Research Council of Canada. Just like the previous four phases of inter pares, I Trust AI focuses on maintaining the trustworthiness of digital records in the long term and on digital means of trustworthy access to and preservation of records in all medium form. What is different among the various phases of inter pares is the technology that each phase examines for such purposes. I Trust AI, as the name says, focuses on artificial intelligence systems. So its goal is to design, develop, and leverage artificial intelligence to support the ongoing availability and accessibility of trustworthy public records. And its objectives are to identify specific AI technologies that can address critical records and archive challenges, to determine the benefit and risks of using those technologies or records and archives, to ensure that archival concepts and principles inform the development of new responsible AI, and to validate the outcomes from the third objective through case studies and demonstrations. So we will present today 3 of the studies that I Trust AI is carrying out. Before then, though, before we start with that, Mohammed, the co-director of Interpares, will talk about AI. Now, Mohammed Abdul Majid is a professor and Canada Research Chair in Natural Languages and in machine learning at the School of Information and in the Department of Linguistics at the University of British Columbia. So there you go, Mohammed.
Thank you very much, Luciana. Hello, everybody, and welcome to this presentation. Um, yeah, I'm Mohammed, and I'm going to talk to you about the artificial intelligence in I Trust AI. This will be the timeline of the talk. So I'll talk about practical considerations that we keep in mind when working on the project. I will give a brief idea about AI, machine learning, and deep learning, and then I will talk about natural language processing, computer vision, speech processing, and then generative deep learning. And I will refer to a tutorial platform that we have created. So our central question, as Luciana has pointed out, is this: can we develop AI systems for carrying out records and archives functions competently and efficiently while maintaining the nature and trustworthiness of the records? So this is the important question that we have. And we have thought about a number of practical steps to start our partnership. The first task that we wanted to look at is this: we wanted to break down the archives functions into tasks for AI because that's how AI will possibly work. And we know that good tasks are ones that are clearly defined. So we wanted also to proceed from the simple to the more complex so that we have a good start. And the methods that we wanted to work with could be existing methods, but we identify these, but we also wanted to develop methods to tackle the tasks that we have identified. And we raise the question, why choose certain technologies but not others? For example, we wanted to be working with state-of-the-art technologies, but also technologies that are explainable, interpretable, and so on. And so the idea here is to identify and develop the technologies and tools that we can actually use to implement the work we have in mind. So comes the idea of data, and Luciana has spoken about what data are and so on, but we also wanted to work with data that we can collect from existing different places, such as municipalities, state archives, and whatnot. And we wanted to identify these data sets, acquire them, but also develop them. So if there's no data set existing, then maybe we can actually develop the data set. And we had a long list actually of questions. So do we have the data that we can use to develop a technology? What format these data are? Can we develop these data ourselves? Are these data labeled? Can we label samples of the data, if not all the data? What about important issues such as ethics, privacy, ownership, respect, community norms, and so on, as we work with people to acquire and develop these data sets? And then we also, of course, wanted to know when can we declare success? Meaning, once we develop a system, how do we know that we have actually developed a good system that delivers to the community? Like that, the use case scenarios that we had in mind are actually working. So evaluation metrics need also to be identified and implemented. And if there is no clear evaluation metric in place, then that's something we also wanted to develop. One very major component of the whole work is training. So we wanted actually to also train a large number of people in the context of this partnership. So we provide a wide range of technologies and methods to develop these technologies, as I will show by the end of my set of slides, a tutorial platform that we have created. With that said, the question is like, what is artificial intelligence? Well, as you can see, artificial intelligence can be thought as a big umbrella. Machine learning is a subset of it, and deep learning, which is very crucial to the work we do in the partnership, is a subset of machine learning. And so there are lots of definitions of what AI is, and it seems to be like a moving target. But here's one definition. It's the study of intelligent agents that perceive their environments, take some actions that maximize their chance of success towards some goal. So this is a very procedural definition of what AI is. Machine learning, also defined in different ways. Here's one definition. So it talks about a computer program that is set to learn from some experience, E, with respect to a class of tasks, T, and performance measure, P, if its performance at these tasks or one or more of these tasks, as measured by P, improves with experience. So basically, we have some software that we build, and we wanted to build that software to optimize some function with a particular goal in mind, and then we have some evaluation metric. Deep learning is the next stage, which I will talk about in a bit, but let me actually show you a very high level idea of different types of machine learning. So we can talk about, this classification of machine learning is in terms of the question, do we have labeled the data or not? If we have labeled the data, so we call this supervision. So for example, we can have data such as books that we know come from Shakespeare versus Dante. And then we can use these in order to develop a system that, given a new book that it hasn't seen before, can classify it into one of these two categories. So we call this supervised learning because we use labeled data. And labeled data is usually something that is coming from humans. We call it ground truth or gold labels. But in absence of these labels, we can also just cluster the data. So we have a bunch of books and we don't know where they are coming from. So we just like cluster them such that each cluster kind of like similar in and of itself. And then we can look at these clusters and try to, assign labels to them manually if we need to. But we don't usually, or we don't have to actually do this manual assignment unless it makes sense for a downstream task. Okay, so one other method that is sort of in between, if we have a small amount of labeled data, then we can use it to build an initial system that we can then use to predict on unlabeled data. And then we use our most confident predictions, for example, to add more data that kind of like, in this case, we call it like silver labels. And then we bootstrap and like we build another system iteratively like this. So we continue doing this process until we have a good system. So this is one class of, or like one type of semi-supervised learning. It's called self-training. There are other types of semi-supervised learning as well. Okay, so this is a high-level idea. What is deep learning? Well, deep learning is inspired by information processing in the human brain, as you can see in the top left panel here. So this is a visual cortex. We see an object, then we don't immediately recognize what this object is. In fact, what happens is that there is some processing that happens in different regions of the brain, and then ultimately we're able to know, okay, so this is a human face. But before that, we can recognize some horizontal lines, for example. And we can actually mimic this behavior by building artificial neural networks that are intended to try to do the same processing that happens in the human brain. So they fire and they interact together and so on. And we can build these networks in different ways. We can have recurrent neural networks, for example, that Luciana talked about. So if you look at the top right-hand side, this is basically a recurrent neural network that is bidirectional. We take some information, we look at it from like right to left, but also from left to right, and this is why we call it bidirectional. And then we can predict, we can like spit out some labels. And then if you look at the bottom right-hand side, these are like two neural networks working together. For example, take some input from one language and then translate into another language. This is usually called sequence-to-sequence learning. And then we can also work with like convolutional neural networks, which is what is intended in the bottom left-hand side here. There are also other architectures. One very important and popular architecture right now is the transformer, which works with some sort of like dynamic method that looks at the data and does what is known as self-attention. It's very successful in natural language processing, but also in computer vision and whatnot. So all of these technologies are important to us, and we work with them, and we try also to improve them and develop newer methods as well. Deep learning has been very transformational. It's very successful. It has made breakthroughs in different fields. For example, biology, astronomy, agriculture, and chemistry. And now is the time to actually apply deep learning and develop methods for deep learning on records and the archives. And that is the main goal of this partnership. It has also made strides on speech and language processing, for example, in machine translation, speech processing, image captioning, and so on. And I will show some examples that belong to these. For example, we can take some text, and then if we wanted to know the grammatical categories of tokens or words in this text, such as, is this word a verb or noun or adjective, and so on. Maybe this information is useful for some task. Then we can do part of speech tagging, for instance, and then we can define like as a tag set, as you can see on the right-hand side here on the top, and then we can work with it, give it like some input, and then we can classify these tokens into different categories. There is off-the-shelf software that works for this for English and a bunch of other languages as well. And it can also be developed for languages for which no part of speech taggers exist. Okay, now here's another example, what we call named entity recognition. So we can take some text such as the one that has Albert Einstein here, for example, and then we can recognize names of people, places, organizations, and so on. And maybe this is like very important and relevant to records and archives. For example, if you look at the image on the bottom, this is actually a marriage license book conserved at the archives of the Cathedral of Barcelona. And we're able to take it, look at it, and identify, okay, this is a name, this is a surname, and this is the occupation, and this is a location. And that's basically doing named entity recognition. Of course, this is in English, but then it can also be developed. And there are actually systems for named entity recognition for other languages as well. And so you can imagine how valuable this could be. Topic modeling is not a new technology, but there are new methods for applying topic models. And it's important because it allows us to discover hidden themes that pervade the collection. So imagine like how large the collections we have nowadays, and then they are getting larger and larger. We can't actually use humans to work on these collections because of their size and volume that is growing very rapidly. So once we discover these hidden themes, we can also annotate the documents according to these themes, and then use these annotations to organize, summarize, and search the texts, for example. So topic modeling is a very important and pervasive technology. We can also do text classification. So for example, we can take some collections, and in the bottom left-hand side here, we can do emotion prediction, for example. So we know like if a sequence of words belongs to a certain emotional category. And text classification is a very widely applicable technology because it can allow us to do things such as classifying if a document, for example, is sensitive or not, which is a very important task again. So you can see this on the right hand side here. And we can summarize documents. So we take some document, and then the document may be very large and so on, but we can like have a nice summary for it, which also saves a lot of our time. We can work on descriptions of visual archives. Given some visual archives, we can develop systems that actually describe them in natural language. And the important thing here is that this description doesn't have to be in English. In fact, it can be in many other languages where machine translation technology is also quite successful in the moment. And here comes machine translation. Not only we can do machine translation between English and, let's say, the top 10 languages, The technology is actually now very successful. If you have recently used Google Translate, you know what I mean. And so we can apply it to a wide variety of languages. In our own group here at UBC, we work on African languages. We work on like several Arabic dialects, indigenous languages of North and South America, and so on. And visual object recognition is a very important task. This is showing where it all starts, like on this ImageNet data set. Now we have like very, very large data sets where we can recognize objects. We can train models to do visual object recognition. We can take this and we can not only recognize what objects are in these images, but also generate captions, as you can see here, for what is in the image. So given an image, we can generate a natural language description of the image, and we can also attend to what is in the image. So for example, in the very left hand side here on the top row, you can see that the word frisbee is underlined, and it's also highlighted in the image. So we caption and then we attend. All right, we can use this in the context of museums, for example. Here's an example of museum image captioning. So given some data, we can actually train these systems to do very interesting things that will make culture very relevant to human lives in different locations and locales and in different communities, which is an intended goal if we want to actually make these relevant, these growing amounts of data relevant in society. All right, we can also do speech recognition and speech processing. So we can do automatic speech recognition. We can develop systems that take text and convert it into speech, for example. You can imagine these being very valuable for different types of functions. All right, I'll talk very quickly about other types of methods that we have in the partnerships and that we are developing and working with, such as transfer learning and self-supervision, for example. So initially, I talked about machine learning as to supervision as three categories: supervised, unsupervised, and semi-supervised. But these are not the only things that exist. We can also work with this idea of self-supervision, which is basically taking running data from real world that don't have any labels, but then we can mask certain parts of these data, and then we can task models to predict the identity of what we have masked. So for example, we do this in text, we do it in speech, we do it in image, and it's very successful. It's behind the popular technology known as BERT, created by Google. It's also now deployed in other speech technologies, for example, such as work coming out of Facebook. We have a host of technologies that we ourselves have developed in language models for Arabic, African languages, indigenous languages. And these have downstream applications in the fields of records and archives. So we call this transfer learning. We use these models that transfers their knowledge to downstream tasks. Deep learning can also be used generatively. So we can have generative deep learning. What you see here is a language model on the left-hand side here that actually can write languages that's very sensible. Humans are able to identify whether this type of language is written by a computer versus a human just randomly 50% of the time. So you can actually look at the text and you don't know if this is written by a computer or a machine. You probably have seen this in the media already. The interesting thing is that this technology can be applied to generate images. And the images here on the right-hand side, they are not very high quality, but they are promising. And then people have taken them and actually developed them further to do like very creative things. For example, given some natural language description of an object, we can generate an image for it, like such as these seeds taking the shape of an avocado, for example. Other technologies that we are developing include, many types of transfer learning where we don't have large amounts of labeled data. Then we develop some, what is known as foundation models that can be used, and they can be applied on tasks with small amounts of labeled data that, and then we can do well with these. We can also do multitask learning where we are trying to do, let's say, machine translation, but also text classification in the same time, or like image captioning and emotion recognition in the same time. This is trying to mimic humans, because when humans learn, they don't learn tasks, in silo. They learn tasks simultaneously, and maybe there will be some positive transfer across these different tasks. We do other types of methods, such as building language models and model-to-model transfer and so on. But in the interest of time, I'm just going to skip these. Other methods include using very novel idea, relatively novel, I would say, like contrastive learning. So that basically tries to make, if we are working with a classification task, for example, we try to sharpen where the data points that belong to each of these categories or classes. So we can try to make it like very distinct. And then we use methods that do graph representation learning. With that, I will just refer to our tutorial platform that we have created. We are continuously adding to it, and it's publicly available, and that's our gift to the rest of our colleagues in the field. Thank you very much. Back to you, Chana.
Thank you very much, Mohamed. Now we will start presenting 3 of the studies that we have been carrying out in iTrustAI. We are currently carrying out about 40 studies. So these 3 have been chosen as representatives of different areas and different archival functions. So the first case, the first study will be presented by 2 speakers. Benedetto Luigi Compagnoni is the director of the State Archives of Milan. He's also the head of the archival superintendents for the Marche region. And after him, Emanuele Frontoni is a professor of computer science via AI vision, robotics, and AI lab at the University of Macerata. Luigi.
Thank you very much, Luciana. And we start with our project. The title is AI in the Middle Age, a kind of oxymoron, but you will know what it does mean. The team of our project is composed by the Archivio di Stato di Milano and Archivio di Stato di Novara, the University of Macerata and Marche Polytechnic University, the University of Pavia, and special thanks to Luca Fois, which is the diplomatics mind behind the slide I'm showing to you, and the Washington University. The importance of ancient parchment documents is there is no way to talk about it, and how it's important to protect and from the physical management, and how is important to let them know from everybody also all over the net. The artificial intelligence, so the representation of digital representation of parchments, reduce this problem, and the artificial intelligence can do that more efficiently maybe than we do now. Archivio di Stato di Milano preserves more than 130,000 documents on parchment, covering nearly 1,000 years of history. The main collections are the Museo Diplomatico and Pergamene per Fondi. The Museo Diplomatico holds the most ancient Italian original private deed, dating back to the year 721, and a large number of documents preceding the year 1000. The Pergamene per Fondi holds imperial and royal charters, papal bulls, chancery documents, and private deeds coming from a huge variety of ecclesiastical and secular institutions of northern Italy, from the 12th to the 18th century. Here you can see an example. On the left, here you have the most ancient original document preserved in Italy's state archives. We are very proud of this document, and we celebrated 1,300 birthday last year. On the right, you can see a papal bull by Pope Clemens IV. And here there is an imperial diploma by Henry the Sixth, the son of Frederick I Barbarossa and the father of Frederick II, the Splendor Mundi. Though studied and edited since the 18th century, this extensive material has not been investigated systematically in order to identify common features recurrent in homogeneous groups of documents. Processing automatically a large number of scanned documents can lead to new understanding of general cross-cutting issues, not related to a single fund. One of these issues is defining the number and the activity of the notaries in the city of Milan and its contado. The AI deep learning approach can automatically investigate a large number of documents and give a substantial contribution to the knowledge of Milanese notaries in the Middle Ages. The basic feature chosen to be identified for the research is the signum. The signum appears in about all private deeds and has a specific and easily recognizable characteristic, shape, position, and so on. You can see some example of the signum, or signa better. The signum or notarial sign is a specific and personal drawn mark used by a single notary before his signature. Identifying the signum means that every notary could be recognized and tracked in a virtually infinite series of documents. The AI will contribute either in create a library of signa and investigate their less visible feature. The AI will be tested for an appearance-based recognition of ancient parchments and documents, implementing the use of AI in the archival science, a method that could be reproduced by many other archives and for different types of documents. For example, as director of the State Archive of Milan, I'm thinking about the Fondi Peroniani and the dream of each director to reconstruct the original funds. And this could be a way of start to reach this aim. It is proposed perganet. Perganet comes from pergamena, parchment, and net, of course, a lightweight DL-based system for historical reconstruction of ancient parchments. The aim of perganet is the automatic analysis and processing of huge amount of scanned parchments. The aim of the project is to use the AI to build up a matricula of Milanese notaries of the 12th and 13th centuries in separate steps. The progressive investigation of all the parchment documents of the Archivio di Stato di Milano will lead to a complete list of notaries and their identification. The process will also generate a list of all the surviving documents related to every single notary. You can see on the right the oldest notarial matricula preserved in ASMI. And it is possible to guess the huge number of notaries created in a year. For instance, in 1337, at least 489. Each matricula registers the notarial sign and the subscription of every new notary who worked in Milan. You can see the steps of the project, but Emanuele will talk better about that. And a test has been performed already on a first group of about 300 documents, private deeds, with the goal to teach the AI to recognize a predetermined number of signa. In this phase, the research is focused on 12th century documents, due of their simplicity, their relatively small number, and the moderate number of notaries in comparison with the following centuries. The first sample is easily scalable by adding material in order to reach the objective of investigate and categorize all the 12th century Milanese documents preserved in Archivio di Stato di Milano and the notaries who wrote them. The oldest preserved matricula of the Notarial College of Milan start from the year 1337. Every new notary was registered in the matricula. The matricula is a systematic tool to know the exact number and identify the notaries who worked in Milan and its contado. The number, the names, and the signa of the notaries before the oldest matricula are only partially known. Several attempts to build up a matricula of the Milanese notaries before the half of the 14th centuries have been done in the last decades of the 20th century, with no effective result. And now I leave the speech to Emanuele, which will talk about the scientific side of the project. Thank you.
Thank you all, and thank you, Luigi. And I will go inside the AI and computer science part of the project. And my background, as Luciana was mentioning in the beginning, is coming from these AI aspects. And I'm very happy also of this interpares project and interdisciplinary discussion, because we learned a lot from Luigi and his team to understand how to work on these parchments. And our goal was to design a pipeline using different deep learning approaches, and the introduction given by Mohamed can help a lot on understanding what we are going to do and what I'm going to explain to you. Why we design a pipeline? Because we want to make some specialization on different neural networks that are able to solve different problems. As you know, now we are inside this concept of narrow artificial intelligence. So we are able to do only very precise tasks and to solve in a very nice way only precise tasks. And that's why we started with the first one, that is a very simple problem, that is the recto verso, the back and front classification of our parchments. Why we need this? We wanted to test if we are able to automatize this task. That is quite an easy task. And to do that, we used a very famous deep learning neural network that is the VGG16. We used a network that was pre-trained in a famous data set that is named the ImageNet, and then we made some specialization using the first data set collected together with Luigi and with the Archivio di Stato of Milano. And starting from this, we was able to run everything also with quite a lot of pixels to manage, and then to reshape, and then to send as an input to our neural networks. We started also to discuss about computational power. And that's why we put this slide here, because every deep learning model needs quite a lot of computational power, and we need to be to have inside our facility some nice GPUs that will help us on solving these kind of problems. And we start training with the very first basic results. What you see here are preliminary results that I will show you. One more point that we want to show you, also showing some of these results of the recto verso classification given by neural networks, is the challenges of this data set. And you can see here, we have a very different lighting condition, coloring of the parchments, but also shapes. You see this one in the middle that have the square very cut and not with the defined geometries. And you know also that we are very, very familiar with images that are very well defined with a fixed geometry, with a square shape or a rectangular shape or something like this. And this is a quite big challenge to make an adaptation of the neural network to these strong differences between one parchment and the other. But finally, the point was reached, and we started also moving forward and try to make text detection. One big point that was also mentioned by Luigi is that we want to be quite novel in the approach, and we don't want to pass by an OCR. We don't want to make a text interpretation or to read something in this phase. All this phase, we call it, this is appearance based. So is totally based on what we see inside the parchment. And what we do here is to make text detection only to have let's say, geographic information on where the text is and how much text is covering in this parchment to allow a better classification of the next steps, or again, to put together the pieces that we designed inside this pipeline. And you had some examples also from Mohamed before about text detection, but also text classification. Now here, what you see here is only the text detection part. Again, we are using a neural network, and we are training this deep neural network. The model of this network is named EAST, and the network was trained over public dataset. Probably the most famous one is CocoText, and we used this pre-trained network also to test and to make some fine-tuning and transfer learning inside the domain of the parchment that you had with you listen from the introduction of Luigi. I can show you here some results. Again, the quality, and I hope you can see the blue square around the text is quite nice. And it's also nice when we have a more complicated shapes and a piece of text that are put somewhere, and the dimension of the text is changed. What does it means? We are quite able to make a generalization of the project, okay, and of the learning and the solution, even if based on a fine-tuning of the final layers of the deep learning algorithm, is quite robust to the big challenges of a parchment dataset. Again, have a look here to understand how far this problem is from a normal OCR of a document coming from an administrative process. And the final step was the third one of our pipeline, and also probably the most novel and the most important. That is the Signa Tabellonis detection and recognition. And you had again an introduction by Luigi about the meaning also for the archival science of this goal and of this task. And what we have done is to try to understand where signa are inside the parchments and start selecting the area where the signa are. And you see there in red squares the area that was selected, also for the manual annotation of the dataset. This is a quite big point, because we need to have in mind every time we start an AI process that we need, first of all, to start having a dataset, and together with the dataset, an annotation of the meaning that we want to reach and that we want to use to train the network. And these red square here are the location of the signa. And you see here as other of them, again with the segmentation. When we discuss about segmentation, that means that we want to achieve not only the classification, but also the localization of a subpart of the image with a certain semantic. And you see here that we had from our colleagues and from the team of Luigi, all the idea of the signa and all the name of the notary, and we started labeling them. And you also can see here that inside the parchment, we can have up to 9, 10, you see here in this example, different signa. And this is another challenge, because these signa are together, sometimes are in different part of the document, and sometimes are very different in terms of the dimension. So we need to be very robust in terms of scaling, in terms of different condition and different geographic displacement of the signa around the document. And you can have a look again to some results. The first one, now this is the dataset, and this is the classification. And you see here that for every signa, for every signum that we classify, we also have a percentage of, let's say, accuracy or confidence that this is a right segmentation of the signa. And just to give you an example here, in the bottom one that you see with the 0.60 of confidence, we have something that is really hard to see. Okay, that means again that we are quite able to understand Signa, and also to make the automatic segmentation. Some more results. Here you have another challenge, that is different Signa that are very quite overlapped. And again, the neural networks works well here. But the basic of this is that we had examples also in the dataset that can train our network to do this in a nice way. Final slide for me. We have a lot of still a lot of work to do. What you see here is a preliminary result of one of the several studies that we have inside Interpares Trust AI project. But what we are now able to demonstrate and that we want to stress is the ability to design different pipelines with very, very specific algorithms that are able to recognize a special system of writing, style of handwriting, but also work on a huge amount of data in a very, very fast and affordable way. And that means that also the computational aspects, the computer scientist aspects, but also the hardware architecture aspects are very crucial on that. We have still a lot to do in front of us, but the problem of joining humanities with the AI is a very nice and engaging problem, and we will try to do as much as we can also to make generalization between different periods of the history and the different archives and different nations and different way of reporting this Signa. The ability to make generalization is one of the hardest point and one of the biggest challenge that we as AI researchers are facing today. Thank you very much.
Thank you very much, Luigi and Emanuele. The next speaker is Umi Asma Mukhtar. She is a lecturer in records management at University Kebangsaan, which is the National University of Malaysia. Umi?
Thank you very much, Luciana, for the introduction. Okay, I would like to proceed to share with our project from Malaysia team, which consists of Cita Sastria is our PhD student, I myself, Umi Asma Mukhtar, Masniza Muhammad, who is the expert in AI, Siti Nur Huda, the expert of AI, and Azman Muhammad Isa, the records management expert. So to ensure the ongoing availability and accessibility of trustworthy public records is central to ensure society's ability to secure human rights and improve governance. Yet, the ever-increasing volume and complexity and the difficulty in controlling them require new solutions. So because of that, we would like to suggest an automated classification model for trustworthy public digital records using text classification and ontology structure. Okay, so the techniques are from text mining techniques and a bit introduction to our project. With increasingly automated means of processing, we are losing control of public records, and ultimately, the public is losing trust in them. As we have seen from other sectors, including finance, health, human resources, criminal justice, implementing automated solutions, especially AI solutions, raises a whole new set of issues and risks, including the financial cost of implementing systems, threats to privacy, data breach, bias, discrimination, loss of context, just to name a few. So there are many risks involved. So this is a time when the IR 4.0 come into picture, and many artificial intelligence has been used into solutions. So we try to use AI to support trustworthy public records in our system. Classification is not just used as a retrieval tool. So if one understands classification as a mere retrieval tool, then its role in the context of record system would be outdated or excessive, given the highly sophisticated search engines which are usually embedded in those systems. So to avoid misconception or misperception of context, classification must be seen as offering other value for ensuring that management is efficient, effective, and competitive. So from here, ICA, an Australian handbook, assert that classification of records enable the following. It goes beyond than retrieval and access, which work to be linked to form a continuous record of activity, changes to the way business activities are described, to be recorded and documented, meaning to be passed on to those who may not have been directly involved in the business that was undertaken, work to be distributed to appropriate people and groups, management responsibility for set of records to be distributed, linked to security and access permissions to be applied to records, and also linked to disposal period and actions to be applied to records. So classification goes beyond than access and retrieval. Since Angie Leland first explored, this is nothing new actually, using the AI into classification, but since the Angie Leland first explored using expert system to classify digital records in the early 90s, there have been several projects looking at the AI in archives, but such projects are typically discrete, often looking at a particular tool in a specific context or even a single set of records. So these studies are limited in scope, only evaluating one or two AI techniques, but still they generally agree upon the potential for AI for classification of the content of extensive collections of records to aid records managers and archivists in their daily work. So records classification offer a concrete example. This is actually my extend extend from my study in 2015, which the issues of records classifications is complex, as it embeds the classic archival science theories such as respect the fonts and original orders, and also diplomatic theory, which we try to use as underlying theories in our project. And it is also argued that the records classification is still an understudied area, as many classification focus on the, as I said earlier, access on retrieval, not on the context. There have been many AI projects focusing on aspect of records and archival work. Also, work being done to find ways to determine and ensure the authenticity of digital records, including those generated by AI, such as applying machine learning to detect forged records or deepfakes, to name a few. But this is our proposed solution. As far as we know, that none of the related studies uses text classification and ontology structure as the approach to classify records and to maintain their trustworthiness. And we use main theories from the archival science, diplomatic theory, and principle of respect the fonts and original order to maintain the trustworthiness, and the other theories also from the AI discipline to support the text classification and the ontology structure. So having said so, our hypothesis is suppose text classification and ontology structure techniques can affect the function-based records classification that support the trustworthiness of public digital records. In that case, the classification process can be more effective and provide trustworthy records for evidentiary purposes. We have two objectives. One is to build records content classification model and record ontology structure for automatic records classification. And the next one, after we have done with the content and structure and context, we build an automatic function-based records classification based on the concept of the fonts and original order to aid with the aid of the text classification models and record ontology structure in objective 1. So our methodology, basically this this presentation focus on the methodology. We haven't started anything yet. We don't have a preliminary result yet as what Emmanuel has. So we don't have that yet, but we plan for the methodology and we try to, this is a kick start for us to start with the project. So we have 5 phases. We have 5 phases. The phase number 1 is for data collection and pre-processing data set. And then we move to the phase number 2, which is to build records content classification using text classification approach. So this is an iterative process until we get the model for content classification, and then we move to the next phase, which is phase number 3, third phase, to build a record ontology structure. This is also an iterative process until we get the best performance of ontology structure model, and then we move to the phase 4 to build the function-based records classification model, and then we do the evaluation by domain experts. So in phase 1, as we call as pre-processing and data collection phase, we will collect or obtain data as archival records from the National Archive of Malaysia, which is also research member in our team, and transform them into a data set. Research activities at these phases are like we extract, and we transform the archival records data, and the text data set extract and transform from archival records, and automatic text labeling based on original records fonts. And then once we're done with that, we do the pre-processing the data set. Most records are in text, and document data sets contain unnecessary words such as stop words, misspelling, etc. Will be removed. And in this phase, pre-processing tasks for the data set, we call that as stop word removal and word stemming. And then we move to the second phase. Second phase is for record content. Record content, which according to its content, text classification assign one or more class labels from predefined set of labels to a document. We given that collection of number of documents and predefined labels, and then we use the original records fonts that automatically extracted from archival records as predefined labels. And then the problem of text categorization can be modeled as finding a mapping F, which is the mapping S is called as the classifier. And then next one, we build the most suitable record content classification. We perform several investigations on the type of features and classifier models, such as we do the feature extraction. Record content in text will be extracted and represented in vectors. and some well-known text representation like n-gram and TF-IDF are chosen and used in the classifier models. And then we do next the feature selection. We'll perform the feature reductions such as PCA and LDA to improve the record content representation further. And last one, we will choose the best classification model, supervised, well-known. We will choose supervised text classifier models such as support SVM, support vector machine, and B bias, um, random forest and decision tree model to classify the content automatically. We will do it one by one, and then the model that classify our record content with the highest performance will be chosen as the text classification model to identify and extract the content type. So this one for text classification, we focus on the content only. And then next one, after we get the best result from the content model, we move to the ontology structure to do the structure and context of records. So this objective for third phase is to build ontology based on the domain of the records used to classify the structure and context of records. So since content records have been classified in the phase 2, we use that knowledge to develop an ontology, additional knowledge as name entities identification, or also known as the name entities recognition, as mentioned by Muhammad earlier. Document linkage, also extracted from the archival records. So we'll do the domain definition, which represent the vocabulary for a generic domain independent of the specific applications. The domain definition generates from records fonts, and then we do the concept identification. Graph is constructed from the name entity identification in the document. The arrangement, relationships, linkage between documents in a record are also adapted when developing an ontology model. And then we do the model development, which generates the preliminary data set in triples RDF format, including the entities and relations with the corresponding confidence score. And then we do the ontology implementation. And next, some refinement. The ontology model cannot distinguish between reliable and unreliable knowledge sources, so deviation could emerge from incorrect and incomplete ontological coverage. So we use knowledge elicitation with a domain experts to address this problem, to exclude irrelevant, illogical, and unrelated nodes and relations. And then last, we perform the evaluation for each triple. And fourth phase and fifth phase, last phase, we build the function-based records classification, assuming the content classification, the content model and the structure and context model are in place, and then we proceed to build the function-based classification. And in this phase, in the fourth phase, with the aid of the automatic content classification in phase 2 and ontology structure in phase 3, we will analyze or synthesize the content, structure, context of a record or new record, and classify it based on the record function automatically. And then in other words, and then the phase will perform records classification automatically by implementing the underlying theories from the fonts and original order, and also the diplomatic theory. So several research activities will be carried out in this phase. We do the knowledge extraction, analyze and synthesize records content context structure using the content classification number 2 and ontology structure in phase 3 to extract knowledge based for generating or developing records function. And then we built the function-based classification model based on the knowledge extraction from previous activities. We will identify completeness, creation procedure, integrity, identity, precise, correct, truthful, and pertinent with the aid of extraction knowledge. We create a function-based classification model. And then next, we also put security part. So we use, currently we decided to use double encryption techniques to secure the dataset and knowledge models. And we classified new records using the, lastly, we classified new records using the suggested classification model automatically. And we get the last phase, we get the evaluation from the domain experts. So those are the methods that we will do to build our proposed model. So this is a gist of the phases that I've mentioned earlier. So I'm a bit ahead of time, Michele. So I am from University Kebangsaan Malaysia, and in our team we have University Kebangsaan Malaysia, University Technology Mara, and also National Archive of Malaysia. So with that, I thank you, and over to you, Luciana.
Okay, thank you, Umi. The last speaker is going to be Jim Suderman, who is recently retired from the city of Toronto in Canada, where he directed the Records Management, Access and Privacy and Archives programs. Jim.
Thanks very much for that introduction, Luciana. Let's see if I can make my slides work. There they are. Excellent. And good day to all of you online. The problem for the study that I'm going to describe starts with the importance of accessing information. About 120 countries, according to the internet, have freedom of information laws, and even more of them apparently have data and privacy protection laws. So accessing information while protecting privacy is a problem that if you haven't encountered it yet, it's likely that you will soon. We also know that volumes of requests for government records are increasing, and the volume of records being requested is likewise increasing. The study is at an early stage, and the participants are indicated there on the right-hand side of the slide, as you can see. It's this study that I'm going to describe is also collaborating with 3 other personal information focused studies. One is based in Europe, another in Mexico, and the third one in Israel. The purpose of the study is to support records custodians. The focus of this study is not on making records available in response to public requests. It is to help custodians understand the records that they have in their care. So many archivists and archival institutions receive government records after a period of time for long-term retention and preservation. And those transfers come with responsibilities, but they often don't come with additional resources. With digital governance increasing, the record transfers are also growing. And as Umi outlined, and even as we saw from the parchments of 1,000 or more years ago, the controls over those records are limited. And so the archives or records custodian has the challenge of effectively balancing the rights of access to government information with the protection of personal privacy that is essential for maintaining trust in governments. So our questions were, can machines be trained to reliably detect all types of personal information? We know that they're being used to detect types of personal information, and so we also wanted to know how effectively machines can currently detect personal information. Our literature review is well advanced. I see my mic volume has been increased. Thanks very much for that, McKelly, and my apologies if I was not coming through clearly earlier. But let me start with the lit review. In the course of our lit review, we found two main approaches for machine learning in the privacy protection space. One was focusing on the records at the point of creation. So an AI aid would say, you're putting in some personal information, does it really need to go in there? And then the creator would decide, yes, it does, and put it in, or no, it doesn't, and maybe leave it out. So that moves some of the risk up to the front of the record's lifecycle. This study is primarily interested in the second approach, which was detecting personal information and doing something with it after the records were already created. The questions that we asked of the literature were what privacy protection risk models are identified and assessed, what machine learning models exist for parsing and labeling text for statute-based types of PI, and I'll explain what that means a little later on, and what success measures are referenced. Our findings, as you can see, was that there appear not to be any comprehensive risk models in the literature, but we are seeing that people or tests of predictive machine learning approaches are indeed risk-based. We are seeing a number of, while we're seeing no comprehensive models, we're seeing a number of elements of a risk model that are showing up. A key one being that that the human in the loop looks like that will be in place for the foreseeable future. And we've struggled a little bit with success measures, not to say that the literature doesn't provide success measures for what they're attempting to do, but the success measures identified are limited to the specific task or focus of the study done. It's not providing a success measure for general PI collection. One of the reasons for these findings might be that privacy protection regulations are framed as risk-based. Are framed as compulsory, but in fact they are risk-based. So let's talk about what PI means. This slide has a lot of text on it. Don't worry about it too much. You've probably read a definition of PI already. These definitions tend to be inclusive. All information that relates to an identifiable individual, that sort of thing. One of the things, though, is that each jurisdiction recognizes that some types of PI are more sensitive than others. So that introduces a couple of things. One is that PI is inclusive. There's lots of PI out there and many types. But that some of those types are more inclusive. So the question becomes, well, what are the types, and which ones are sensitive, and how would we know those things? But we need to understand PI, how it's defined, if we're going to develop labels to effectively enable a machine to learn about it. So let's talk a little bit about labels. British Columbia, on a government website, lists about 32 types of PI. This is not from the statute. This is from guidance text on a government website. Some of the types are specific. Some of them are more general. For the target body of records that we're aiming at, we may have personal information of individuals from other jurisdictions, including, for example, the European Union, where the GDPR becomes a factor. And in terms of identifying sensitive PI, we didn't find any guidance from the British Columbia government per se, but from reading the reports of the regulator in BC, it becomes clear that sensitive PI includes biometric and health information, but it doesn't provide a list of what PI is actually sensitive. And maybe part of the reason for that is personal information, PI, is content focused. So if my birth date is in 1961, then that is some content. 1961, the year is content. But sensitivity seems more context focused, not content. And to try to illustrate this a little bit, I have three pictures of King George III on the right side of the slide. One is a portrait of him as reigning monarch in 1800. Another puts him in the middle of a movie poster from 1994, with the movie title being The Madness of King George. And then for those of you who've seen the musical Hamilton, 2015, the King George character is really only a bit character, an important bit character, but not a main character. But even so, it was important to put the fact that he was mad into how that character was shaped on the in the musical. And so you can see that sensitive information, like mental health information, has moved from being more or less invisible in the portrait while he was reigning to sort of a key element in how the individual is represented 200 and 220 years later. So that's one of the challenges with PI labels. And we thought, well, this is very complicated. Maybe we should just use an existing published label set. Why don't we do that? Because otherwise this is going to be a lot of work. So we went around looking for published label sets. We didn't find very many. We just found the 4 that you can see across the bottom of the deck of the slide there. And we compared them against the 32 types of PI that we see listed by British Columbia, and found that a significant number of types, 12, 16 to 20 to 24 types of PI might not even be present in existing tools as label sets. So it looks like if we want to do a study on comprehensive labeling of personal information, we're going to have to build on work that's already done. And I think, just to make sure I nail the point home, if we're using a tool that only detects 8 of 32 types of PI, it's probably reasonable to assume that the other 24 types of PI will not be found by the machine. And so our ability to understand the scope of PI in a body of records is reduced accordingly. So from PI labels, let's say we get our PI label set built. Now we have to move to the labeling of the PI. And just for your interest, I put a graphic from Cognilytica there in the right-hand side of the screen, which shows time allocated to machine learning project tasks. That about 80% of the time is focused on the data. And I included that for this audience because I thought data is something that we as archivists and records keepers know something about. We may not work with data per se, but the records we work with are jam-packed with data. And we've been busy talking about ways of extracting and making use of the data that they include. So labeling, the literature identified a number of labeling challenges with PI, and a key one was there's no gold standard. There is no, this is the correct way to label this kind of information with this label. Experts who know a great deal about privacy protection and categorizing of protecting privacy will disagree on whether some information is PI, on whether it is a particular type of PI, and on whether it is a sensitive kind of PI. So a key function for us as we look ahead at our study is, are we going to be able to apply PI labels for all the types that we want? And are we going to be able to do that consistently so that a machine learns a fairly dependable, reliable way of labeling, of sorting through the information and applying labels. We've also begun an algorithm review. This is essentially a kind of literature review, but the focus is on the algorithms named by the studies, and the algorithm review was conducted, is being worked on by people who are knowledgeable about these things, not me. You can see that there's a wide range of algorithms that are being applied against PI detection. The algorithm review is recommending additional research to comprehensively address the problem of PI detection in a sequential way. What this would mean would be, I guess, establishing a comprehensive body of PI, using the semi-supervised learning. I think that Mohammed described at the outset, it would iteratively become an increasingly effective way of detecting PI in a space, and that would be the sequential reference that's here. So we are being challenged by establishing our labels. We know we have a challenge to overcome in applying the labels. We also are having a challenge identifying a training record set. So we've got a target record set. It's a body of administrative records held at the University of British Columbia Archives. And it is comes from two offices named there, the Provost and the Deputy Vice Chancellor, about 15 gigs, fairly recent records, last 20 years or so. And while we have approval to use the records for the study purpose, in principle, we need, before we have access to them in practice, we're going to need to sort through a number of issues ahead of time. So the target set, describing the target set to you is a means by which we thought, well, okay, what kind of training record set will we need to work effectively on this target set? So we're trying to link our training records to the characteristics of our target set of records. Our first thought was, well, maybe we could look at the fish rot files. That is scandal, records were published some time ago, but we found that the records were not all in English, which was one of our parameters, and there didn't seem to be that much PI in them. The two sets of emails listed there look better from a range of PI perspective, but they don't have a range of record types. They're just all emails. Currently, we are considering applying to the US federal court for access to federal court records. We think that'll have a wide range and has an additional benefit of us knowing quite a bit about how the records came into being. So again, another call out, if you know of an excellent training set of administrative records that we might use, please don't hesitate to contact me. So let me end with some preliminary study findings. Firstly, available PI detectors are not comprehensive. This doesn't make them useless or problematic in any way, other than the people who are using them need to understand what their limitations are and how those apply in their jurisdiction and to the records that they're using the detectors on. Why aren't they comprehensive? Maybe variations in juridical contexts, the absence of a gold standard for classifying PI and assessing sensitivity, and lack of comprehensive record sets for use in training machines. Risk acceptance in the public sector maybe varies by type and sensitivity of PI, but the risk acceptance seems to incline to, well, we will reduce access at in order to privilege privacy protection, because if we don't provide access to records, then no privacy can be breached. Fair enough, I understand that logic. It may not be viable indefinitely, particularly since we know backlogs grow, and it's unlikely that we will be able to work through our backlogs without assistance from machines. So we think we're starting to see some opportunities emerging for archives and archivists. One might be identifying large-scale record sets with many types of PI. So that might require some modifications of our approval process, an appraisal process, not just is there PI in here, but what types of PI are in here, and consider the records from that kind of perspective as useful for a training data set or a test data set for a potentially new type of client, which would be the members of the AI community. I think also archives and archivists have an important role in developing research agreements, partnerships with machine learning initiatives that are sensitive and respectful to the subjects of the records. So let's not just use this as an extractive function where we try to extract everything of value without particularly worrying about the consequences of doing so. So I think our research agreements and partnerships need to be respectful, recognize and respect the subjects of the records. And part of that may be from continuing work with regulatory authorities on risk mitigation steps for using machines to help balance privacy protection with openness, access to government information. This might be enhanced privacy impact assessments, for example, that routinely include data management plans. It's not clear how this might go, but these are some of the opportunities that we're seeing. Well, I hope that has been of some interest to you, and thank you very much for your attention. I look forward to responding to any questions you may have.
Thank you very much, Jim. So now it is my turn to close. The three studies you have heard are only to give you an idea of the kind of work we're doing. There are more than 40 studies going on. We started the entire research project last summer in 21, and we have 5 more years to go. We will keep you updated on what goes on. In the meanwhile, if you want to follow us, you can see that we have 2 journal studies. And of course, the first one, Terminology Database, AI and Archival Terms, is pretty fundamental because this is an interdisciplinary research project. And the first thing we must be able to do is actually to talk to each other and understand each other. So we have this terminology database on our website, and we will keep updating it as we adjust our terminology according to our findings. Also, there is an AI and machine learning tutorial repository, which will be accessible to everybody. And so people can learn better about AI tools and the methodology used. There are, among the many specific studies we are carrying out, there are some that may be of specific interest to archivists who are listening to us. For example, one is about disaster data. So how to acquire and preserve data of natural and human-made disasters within their context and provenance, and document all of this using machine learning. Another one is the smart grid data communication and analytics. So really the ability to keep this data in a trustworthy way and be able to navigate them and to preserve them. Also, building and creating a digital twin for preservation. Now, this is a new technology. You know, traditionally we do blueprints for buildings. Well, now we are creating images, digital twin, that we need to preserve over time, but in order to carry out the activities and to preserve evidence of them. Then, of course, there is a study on identifying and reconstituting archival aggregations of digital records and enriching metadata schema. The aggregations of digital records often naturally grow up, but they're not necessarily all that we need. Think of this. We have all the email together, for example. We have all textual documents together or all the pictures. Well, we must be able to contextualize them all and show them and make them accessible as parts of activities and processes, which means that artificial intelligence can help us there. Also, we are doing a study on retention and disposition of digital information in record keeping systems. We are doing a study on curricula. So curricula specifically for arrangement description and how we can teach artificial intelligence for those purposes. We're doing a study, this will be of interest to most archivists on the ICA, on intentional logic-based AI for records in context conceptual model, RIC, CM, and ontology. Also study on enterprise master data management and the role of metadata. This is specifically in the private sector and corporations like banks. We are doing a study on how to preserve the artificial intelligence techniques and tools that we use carrying out our archival function as paradata. So we do need to have that information together with the outcome of the use of AI so that we will be able, in case, issues come up, to see whether the issues were caused by the techniques used and how the data that we have, the result from the use of techniques, can be trusted. So this is also a lot about transparency, right? And accountability. We also building a model for AI-assisted digitization. We are using AI for gamification of the archival experience for users. So this is within the Access working group. We're using it for declassifying personal information and also for studying users' approaches and behaviors in accessing records and archives. So you see, there is a large variety. There are many more studies, and they are almost equally divided among the various records and archives function, from creation and use to reference and access. What are the expected outcomes? Well, the project will improve upon existing tools and create new machine learning tools that will address archival needs. For example, machine translations, image recognition and description, optical character recognition and then written text recognition, text summarization and classification, and text style transfer for language civilization, like the removal of biases, of hate expressions, and of sexism, for example, from old inventories. What are the indirect outcomes? Well, we definitely will generate new professionals. By the end of the project, there will be over 100 professionals who will have worked as student research assistants on case studies with testbed organizations and who will spread acquired knowledge. And of course, without counting all the future professionals that will be taught all this knowledge in class. We have so many universities involved in the project, and this, of course, will produce lots of professionals who will be knowledgeable about AI. Also, students from other disciplines like computer scientists, lawyers, engineers will understand and value the archival perspective in their work and the impact of records and record keeping on society. There will also be knowledge co-creation in the sense that the project will enrich research not only in archival science and records management, but also AI, cybersecurity, information science, law and ethics, through knowledge exchange and uptake between scholars and practitioners within and among those disciplines. We also aim to sensitize AI developers, scholars, and other members of the community to the role of AI in record keeping and archival preservation, and to the role of archival concepts and principles in AI design and development. The participants to date are 87 public and private organizational partners in 5 continents. They include universities, archives, businesses, corporations. We have 117 co-applicants from academia and 93 professionals, and 30 graduate research assistants at this time, which is less than a year, so there will be many more. If you want to learn more about us, you can go to our website, interparestrustai.org, and to our various accounts on Twitter and on Facebook. And I am sure that my co-director would like to say a few words before we close. Mohamed?
Yes, of course. Thank you very much, Luciana. I would also like to thank all our speakers, Luigi, Emanuele, Umi, and Jim, for a fantastic set of talks here. I would also like to very much thank everybody who has invested from their valuable time to be with us here today, to learn a little bit about the work we are doing. And I would like to emphasize that we so very much look forward to engaging with everybody and working together side by side. As Emanuele pointed out in his talk, this is a unique, I believe, opportunity for computer science to work with, records and archives specialists and professionals. And we very much look forward to this valuable opportunity that we hope will be an example that can be modeled after. We are excited about this, and we will generate new technologies that are hopefully transformative, that will be valuable to society. Last thing I would like to mention here, I also wanted to just acknowledge that I'm speaking to you today from the University of British Columbia, which is on the unceded territory of the Musqueam people. I'm very privileged to be here, and I believe that we can build together with all the indigenous communities for a better future for everybody. Thank you very much again.
Thank you, Mohamed. Thank you, Luigi. Thank you, Emanuele. Thank you, Jim. Thank you, Umi. Thank you, Michele, all the organizers. And thank you to the audience who have had the patience to be with us. Goodbye.
Thank you all.